Very good morning to all, and welcome all for this distinguished speaker program on Spill the Beans, Artificial Intelligence, Machine Learning, and Deep Learning. Today, our distinguished speaker is Dr. Aswani Kumar Cherukuri. He is professor in the School of Information and Information Technology and Engineering, VIT Vellore. I wholeheartedly welcome you, sir, for this event. I welcome all the students, all the participants who have been here to attend this session. So, just a brief introduction about the speaker today. Dr. Aswani Kumar Cherukuri is a professor at School of Information Technology and Engineering, Vellore Institute of Technology. He holds his bachelor's and master's degree in computer science from Acharya Nagarjuna University, India, and a PhD degree in computer science from Vellore Institute of Technology. His research interests are information security, machine learning, and quantum computing. He was also a recipient of Young Scientist Fellowship from Tamil Nadu State Council for Science and Technology. Also, he was a recipient of the Indian Express Inspiring Teacher Award under 14. He has executed few research projects funded by the Department of Science and Technology, Government of India, Department of Atomic Energy, Government of India, Ministry of Human Resources Development, MHRD, Government of India. He has published more than 100 referred research articles so far in various national, international journals and conferences. He had also delivered technical talks at several national and international conferences. He is also the editorial board member for several international journals. Dr. Cherukuri is a senior member of ACM. He has organized a 3-week summer school on information and system security in association with ACM India during May and June 2017, which attracted students from across the country. There is a lot much to say about sir. So I wholeheartedly welcome our speaker today, Dr. Aswani Kumar Cherukuri sir. Welcome to the event. Uh, Over to you, sir. Sir, am I audible?
Yeah, good morning, sir. I'm just making the slides visible.
Yes, sir.
So, are the slides visible, right?
Yes, sir, they are visible.
Okay, thank you. So, at the outset, I would like to thank the wonderful introduction that was extended to me. And first of all, I would like to congratulate uh, the ACM student chapter of Gokpe Institute of Technology, Belgavi, and Professor Srivatsa Perur, who is the faculty sponsor of the ACM student chapter of this institute, for inviting me to deliver this talk. Uh, I would like to congratulate all the students who have joined this the talk, and also I would like to thank my the head of the department and the principal and authorities of this institute for taking the steps in the interest of students, and so that the students would get benefit out of this kind of talks. Okay, so my talk today would be on throwing some light on the artificial intelligence, machine learning, and deep learning. Sir, am I audible, right?
Yes, sir, you're audible.
Okay, so thank you. So my talk today would be focusing on these three angles, providing a better perspective of artificial intelligence, machine learning, and deep learning. What happen is we generally think all three are same, or in an interchangeable manner we use these notations of artificial intelligence, machine learning, deep learning in a very loose manner, in the sense or else in a very broader manner, without knowing into the deeper aspects of what is each. So my talk would be covering some of the the fundamental concepts of these three the pillars of artificial intelligence, machine learning, and deep learning. And at the outset, I would like to mention about the association, which is the premier association of computing professionals across the globe, ACM, which has about more than 1 lakh professionals, including students and computing professionals, both from academia and industry. It's a large global community, and which has spanned across more than 170 countries, and it is interacting with more than 2 million professionals across the world. And I sincerely wish that all computer science and information technology related disciplines, students and faculty members should become the members of the ACM and get benefit out of this large professional body. And the main mission of the ACM is to help the computing professionals to execute and to do their best in a most creative manner, whatever the responsibilities that they're executing, or learn as much as they can from others, or from the manuscripts and the technical documents about the latest developments, and also get inspired by the professionals and the developments that are happening in the computing discipline. And I'm happy and proud to be an ACM member, and I'm ACM member from the last 14 years, and at present I'm the senior member, and I have got immense benefit from the community of ACM in terms of learning and getting inspired by the contributions of the professionals. And this particular talk, what today we are experiencing, is a program through distinguished speakers program. That was this particular talk is made possible, and the ACM supports this distinguished speakers program by identifying and providing support to the professionals in talking to the various student professional bodies across various institutes, and that to get the knowledge from the professionals. So I strongly suggest all the student community to become members of this professional body. And nowadays, from past 2 to 3 years, ACM India is very active, and the membership fees is also reduced. And if you once you become the member, you will really enjoy the benefits of this particular professional body. Now, this is the formality that any distinguished speaker should talk about the society in the first 2 slides. So that's the formality. So now let us go to the today talk about understanding the AI, machine learning, and deep learning. And I'm sure that all of you are from computer science discipline, or probably from different other disciplines also, maybe there. But typically, if you observe nowadays, the machine learning, especially machine learning and deep learning techniques, are widely deployed in almost all disciplines, whether it is core computer science, or maybe for the electrical, electronics, mechanical, civil, name the discipline. Nowadays, you don't find any discipline that was not touched by the technical algorithms, technological algorithms, the machine learning, deep learning algorithms. So I'm sure that this particular talk would throw some light on getting the different perspective of AI, ML, and deep learning. So this talk would be focusing on the broader spectrum of artificial intelligence, and also what is actually artificial intelligence. And then what is meant by machine learning, what are the problems, what are the tasks, what are the techniques, what are the algorithms of machine learning, and similarly what is meant by deep learning, and how actually all these things are similar in nature, and also how all these things are different in nature. Okay, so what are the similarities, what are the differences, and then also we will look at what are the various toolkits that people are using. Of course, I'm sure that many of you must have got experienced with have experience with Python. Sir, Professor Perur, sir, are you having Python in your curriculum?
Yes, sir. We do have Python in our curriculum, sir.
Okay, and these students are already have learned Python, right?
Yes,
Or
sir. Few of them are learning and few of them have learned, sir. We have a hands-on
yes,
also on this. We have lab sessions also on this.
very good, very good. That's interesting. In fact, the Python is one of the prominent pillar that is
Yes, sir.
pushing the machine learning and deep learning algorithms, and because it has the built-in libraries and APIs and toolkits that students can use it and play. But
Yes,
only
sir. We
thing is
also
that
have
what
this
I said.
artificial intelligence as the subject, sir. For 7 semester students, we do have
Okay, sir, that's
artificial
good.
intelligence also.
That is good. That is good. That's really good. So the point is that what I recommend all the students is to use the various libraries and then play with them and try to understand and learn. But the point is that no, you should not lose the coding skills. In case if you are using the built-in APIs and libraries, you are making a function call. Imagine you want to perform a classification. After all, you can call a API and then use that built-in methods for classification purpose. But as a computer science student, you should actually really try to understand how to write the code for a classification. Okay, how to perform the clustering, how to perform the prediction. So do not stop with only using these APIs and libraries, but try to code them, because that's the coding that gives you a better understanding of the algorithm. If simply you use the APIs and libraries, you may be solving a particular problem, but you don't understand completely in depth about the particular algorithm, how it is working and all that. So now let us go ahead and then understand what is AI and all that. So the transformative nature of AI in business and also in our society, not only in business but also in our society, is evident. Nowadays we are getting the gadgets even to our hand which are AI enabled. So like the internet and the smartphone, AI is an enabler technology. It is going to enable, or it's already enabling almost all disciplines, and it will have a far reaching impact on almost all areas of our life. Name the discipline, name the area, AI is making the impact, and in the days to come you will be having more and more impact. And in fact, if you observe, one point I would like to mention about the artificial intelligence as a course. See, as Professor Perur was mentioning that you guys are having an artificial intelligence as a course. Probably some of you must have done, or some of you may be doing it. You understand better now, okay, what you are learning in the classroom from the textbooks of artificial intelligence, and what you are practicing in the community through certain toolkits and the APIs and the libraries, what you are doing, you will see that there is a kind of a difference. What you are learning in the classroom in terms of solving the problems, but in terms of what you are learning, what you are doing in the APIs and libraries is, like you are using the certain, you are using actually certain libraries. So your classroom is making you to develop, but actually in practice what you are doing is you are actually using rather than developing. Okay, so don't get confused. Don't think that my classroom artificial intelligence course is too theoretical, too boring, I'm not able to understand. Only thing is that if you stop using libraries and if you write your code on your own, that means your classroom learning is making you help. If you are simply using the APIs and libraries, you computer science students should understand, not only you, a computer science student can do that, even a mechanical student can do, even a civil engineering student can do, who knows who knows a little bit of programming. So how a computer science student distinguish from other students is about developing the code. So your classroom learning of artificial intelligence helps you to develop the code and design the code, whereas the APIs and libraries will help you use it. Okay, so I think this is the broader thing which you need to really remember. I think because I always see the student think that my AI class is boring, whereas I'm doing a lot of fun stuff in my beyond my classroom. This is the line of difference that you guys should understand. So AI is a branch. What is AI? AI is a branch within the computer science. Okay, if you understand the evolution of computer science, if you observe, about 80 years back, there is no some branch of science called computer science. Yeah, it all started about in 1940s after World War II. Okay, so that means it's very, very young when compared with the other disciplines of science like mathematics, biology, or physics, chemistry, and all that, which have the centuries of history. Whereas computer science is after all about 80 years. But look at the way the computer science has impacted the entire society. The technological development that took place in the entire civilization, the technological development that took place after World War II, we call them as the internet revolution or information revolution or fourth industrial revolution. Okay, but it's all because of the developments that have taken place in computer science and other allied disciplines, especially electrical and electronics engineering. So the computer science, the AI is a branch of computer science that studies how to create machines and which has the capabilities similar to the human intelligence. Okay, so earlier days, when in 1940s and 50s and 60s, when computers were introduced, they're mainly aimed at solving certain tasks which humans are repeatedly doing it. Okay, are a kind of regular tasks. But at the same time, there was a proposal from the scientists about building intelligence machines which can mimic the human brain behavior. And if you observe that, AI is a very broader term. There are several maturity levels of artificial intelligence. One is called super intelligence, general artificial intelligence, and narrow artificial intelligence. You need to really understand what is these three maturity levels, and currently we are at which maturity level. So our goal is, the artificial intelligence goal is to achieve the super intelligence. That means the machines should exhibit the capabilities that are higher than the human beings. Okay, and that is the super intelligence. So that is the topmost level, wherein which that what we see in the the imagination movies and all that, like the best example is the popular robo film that what we saw in wherein which Rajnikant playing a kind of a robo performing.
No.
Our capabilities, our human cognitive capabilities. Can somebody ask you to write the rules or how you are doing it? Can somebody can explain it? It's very difficult to explain. What is the logic behind all these activities? In a similar way, AI is very useful in order to digitize our cognitive capabilities. But how can you digitize it? Now, after all, you need an algorithm. If a computer has to perform certain tasks, you need an algorithm. But how can I write an algorithm? If you have certain set of rules. But where are the rules? In the case of developing the human, or in case of programming the human capabilities, there are no such rules. Okay, after all, you may say certain rules for certain tasks what we are doing, but the entire set of tasks, if you want to write the rules, it is very difficult and it's not possible as well. So the best example is the face recognition. Look at the small kid. If he see his mother, small kid, she or he, if they look at the small kid of say even the 1 month old or 2 month old, if they see their mother, obviously they're after 3 months, slowly when their emotion starts developing, they will smile. How they are smiling it, and what is the logic behind it, and how they are able to identify that this is the mother. I should so if suppose somebody has to write a program for that, how can they do that? And about that, nowadays, our cameras in the mobile phones and the software inside that mobile phones are able to do the face recognition. Okay, but means, and our machines are getting unlocked or locked because of the facial recognition features. Means we are able to come to the face recognition problem to some extent. But if suppose we want to perform certain emotions and all that, still we are trying to mature it. Thanks to the technology of image processing and the machine learning algorithms and all that, face recognition is matured a lot. So what is AI? AI is the ability of machines to perform functions similar to that of human mind, like perceiving, learning, and problem solving. Okay, so that is the very broader spectrum. Under that, you have machine learning. So machine learning is a subfield of artificial intelligence, and which is referred to ability of computer systems to improve their performance by exposure to data. Okay, so this is very, very important. So machine learning is a branch of artificial intelligence, means it's a subdomain of artificial intelligence, number one. And number two is it has the ability of the computer system to improve their performance. How they will improve their performance? It is purely based on the data that is available. Imagine if you don't have data, gone. Your machine learning algorithm or machine learning techniques do not work. So the backbone of the machine learning is the data. Remember one thing. Look at the artificial intelligence, what you learned in the class, especially those students who have learned. It's not on the data, right? The faculty would not teach that for AI, data is mandatory. So machine learning is a field of the branch of artificial intelligence. In what way? To build the intelligent machines. But how it is different with the core artificial intelligence? For machine learning, you need to have the lots and lots of data, and without it did not has to follow certain explicitly programmed instruction. So you expose it to the data, and the learning model would acquire the intelligence. Now the third point, what is deep learning? It's a type of machine learning, means it's a sub branch of machine learning which sets up basic parameters about the data and trains the computer to learn on its own. So in the case of machine learning, you have to train the model by saying what are the features and all that. In the case of deep learning, you just give the data and leave it. The deep learning model would automatically set up its basic parameters, the features, and learn on its own. Okay, on its own by recognizing the patterns. In the case of machine learning, it has to be done by the human expert. Okay, so the AI is a very broader spectrum. Under that, the machine learning is a subfield, and it is based upon the data. And the deep learning model differs. It's a branch of machine learning, and it differs from the machine learning in the sense that you need not have to explicitly mention what are the features. Say, take an example. Imagine you want to recognize a cat. In the case of machine learning, you need to explicitly mention the features of a cat and train the model. Whereas in the case of deep learning, you provide the data samples to the say cat to the learning model, and the learning model would automatically extract the features and perform the classification or whatever the kind of task that it need to perform. So these are the three pillars. In fact, today we would be talking more on these three angles. So the AI, the machine learning, and deep learning. And while doing this learning, and you will come across three types of learning. One is called supervised learning, and people call second one is the unsupervised learning. Third one is the reinforcement learning. So in supervised learning, you need to provide the data, and also along with the data, you need to provide certain description of the data, in the sense that, look, this data this is the one. So in the sense that when you are it's kind of a labeling you are giving. For every data sample, you need to provide that label. So the machine is trained on the data, remember, which is labeled. So the label is kind of a supervisor telling the machine learning model, saying that, okay, when you have these particular features, this is the cat. When you have this type of features, this is say dog. When you have this type of features, this is say another animal called rat. So this particular label of data is making the learning model as a supervised learning model. So the learning algorithm can also compare its output and say whether I have learned correctly or not. How you are matching that with the labels that what we are already providing. Okay. And in the unsupervised learning, data that is used by the machine learning model, you don't have any kind of labels. So you provide only the data and then no labels to the data samples, and the system does not figure out the right output, but it explores the data and can draw the inferences from the data sets to describe hidden structures from the unlabeled data. So it's kind of a clustering analysis. In the clustering analysis, in the sense, you provide certain the human features and then ask the system to cluster it into two groups, say male and female. So if it is automatically performing without any kind of a labels or without any kind of a supervised approach. And in the case of reinforcement learning, it is exactly, or in one way we can say that the reinforcement learning is like the way we actually learn, especially the humans, right from the childhood, how they learn, in the sense that, if you observe, it is through kind of an experience. Hello, sir, am I audible?
Yes, sir, you're audible.
Yeah, sure. Thank you. So in the reinforcement learning, after all, we get an experience. Okay, so it is like this: there is a fire, and there is a small child who is playing. Okay, and you keep telling the kid that don't go to the fire, don't go to the fire, don't go to the fire. It's kind of a supervised learning. When the kid goes towards the fire, imagine kid experience some kind of a heat by touching it or some kind of an experience, and kid understands that, okay, next time I should not come this side. So means training on her own, that I should not go to an object which is hot, or else I should not go to a kind of a flame. So it is through learning through experience. So what happens is, in the kind of that such type of experience environment, you learn by experiencing it, in the sense that the experience will tell you whether it to get some kind of an award could be positive or negative, in the sense that, imagine if the kid goes to the flame and then experience that heart, it's a kind of an experience and it's kind of a reward. So typically it would be modeled through a function called reward function. Okay, and from that reward function you optimize your behavior, and this is called reinforcement learning, which typically we follow as a human beings. So in this model, the learning method interacts with the environment, as I've mentioned, by producing actions, and then you discover the errors or rewards. Okay, yes, my reward, no, I gave a talk and I got an appreciation. I gave a talk, I got some kind of negative feedback. I correct myself. I'm preparing a dish. While I prepared the dish, I put some ingredients and I got a very tasty dish. Okay, I got a reward. No, my dish is not so tasty, and I correct myself from some certain, I correct my actions. So this is kind of a reinforcement learning. These are all the examples of reinforcement learning. So now how you bring all this to the learning environment? After all, why we have to learn? In order to acquire the intelligence. So without learning, there is no intelligence. So there is nothing like you make the intelligence machines. So these are the three pillars. One is AI, machine learning, and deep learning. And then the categories of learning are supervised, unsupervised, and reinforcement. And there are various the use cases why to go about for the AI and all that I think all of us are aware, and we all know. So the fundamental unit or the inspiration of this machine learning models or the artificial intelligence model is the human brain. Okay, so this is the human brain is a complex system wherein which after all, we all know that human brain is very complex, and not only in terms of scientific in nature, but also it is very difficult to understand one each other, right? Every individual on this planet of Earth, about 700 crore population of human beings, everybody is unique in nature. Their emotions, their thoughts, their language, their actions, their features, the physical features, and above all that, the way they think, everybody is unique. No individual think alike. Okay, it's very difficult to find people who thinks alike. Okay, of course, it all happens only in the films between hero and heroine, but generally it will not be the case. So the human brain is a very complex in nature, and it's a if you observe, there are about 100 billion nodes in the human brain. What is a node actually? A node is a neuron. Basic unit is a neuron. We have about 10 power 12 or 10 power 13 neurons in the human brain, and all these neurons are interconnected. Okay, and hence you have about 700 trillion edges between these neurons. So these neurons are processing with each other, connected with each other, processing at a very faster pace. Even now, all of you are listening what I'm talking. You are looking at the slide, and at the same time, some of you may be listening to the music, some of you may be listening at a movie, some of you may be watching a video, some of you may be listening to something else, or some of you may be even getting sleepy. Now, all these things are happening. Your brain is processing at a very faster pace because of the 100 billion nodes, which are the biological neurons connected with each other, forming about 700 trillion edges. So that's why, if you observe, we are able to have memorizing things. We are able to represent the information. We have sensors. We have sensors which are receiving and processing the information. We are able to recognize things, and we are able to perceive things. We are able to comprehend. I keep talking, you are listening, and you are trying to understand and comprehend something, and then develop with the strategy. Upcoming I'm going to have my placements. Upcoming I'm going to have my GRE. Upcoming I'm going to have my university examinations. How I should prepare. All that, these are the strategies. So all this is possible because of this complex small component in our body called the brain. And if you observe, there are a lot of the way you can divide the human brain into various parts, wherein which if you see, there is a frontal lobe, and there is a parietal lobe, and occipital lobe, and temporal lobe. These are the various lobes in that, and which is having a lot of this human the neurons and all that. And these various parts of the brain are performing certain various tasks. Like if you see visual cortex, auditory cortex, then there is a Broca's area, which is mainly meant for production of speech. Then there is a prefrontal cortex, and this is people have identified the various functions that what we are performing are being done at various parts of the brain. Okay. And now, if you observe the way the human brain looks when compared with the brains of the other species, mammals, especially mouse brain, then the chimpanzee brain and the human brain. Okay, if you observe even the evolution of the humans, the way the human brain got evolved, if you see here from the earlier days of Neanderthals to the current Homo sapiens, you see the way the human brain got evolved in our skull, inside the skull, the way the human brain got evolved. Okay, so now because of these developments, the evolution that took place over centuries of years, the millions of years, at present we are able to perform various complex tasks. Okay, and if you put all these things, complex tasks, before that, our ability to process the information, okay, ability to process the information, we are able to do it because of, number one, we are able to perceive, we are able to learn, we are able to abstract, we are able to reason about the things. Okay, now if you observe, perceiving, learning, abstracting, and reasoning, if you put them on a notional intelligence scale, reasoning is highly intelligence. Perceiving it's about the half of that, called as the intelligence. Okay, so A is program ability to process the information. Okay, so after all, you need to write the program. It is about ability to process the information the way human brains process. how we process by perceiving, learning, abstracting, and reasoning it. Now there are three waves of artificial intelligence. One is the handcrafted knowledge, statistical learning, and contextual adaptation. If you observe what is handcrafted knowledge, it is about, like, you play a chess game, okay, and that's why if you observe the chess game as one of the highly intelligent, somebody is playing chess and winning the games, that people call it as highly intelligent fellow. So the reason is there is a lot of uncertainty inside the game, and the perceiving is to some extent, but learning and abstracting, if you observe handcrafted knowledge, there is a lot of kind of an uncertainty. Whereas the case of statistical learning, you have perceiving, you have learning, and you have less amount of abstracting and reasoning. Okay, and essentially the kind of problems what we do in the case of statistical learning is the classification and prediction capabilities. Of course, there is no contextual capability, so you don't adapt any kind of a context to the problem in the case of statistical learning. In the case of handcrafted knowledge, it is about reasoning over narrowly defined problems. Means, you have a chess game, you have a chess engine, that the engine has the knowledge to solve the problem of, or to solve the the chess game, or to play the chess game alone. So it is precisely defined to solve that particular narrow problem, and there is no further learning capability, and it's a poor handling of uncertainty. In the case of contextual adaptation, now the point is that if you see here, there is a training data, there is a learning process, and above that there is a kind of an explanation model, and it is telling, I am taking this decision and I am explaining why I took this decision. Okay, so this is called contextual adaptation. So in such model, what happens, you will have perceiving, you will have learning, you will have abstracting, and also you will have reasoning. So now the point is, if you observe slowly, we looked at the handcrafted knowledge problems, wherein which you solve certain narrow problems like a chess engine. Okay, and you know very well that if somebody is cracking the chess, you feel that that fellow is an intelligent fellow. And you have statistical learning problems. There are applications nowadays which are able to perform the statistical learning. But coming to the contextual adaptation, we are yet to reach to the level of achieving the contextual adaptation. So there are many intelligence in the case of handcrafted knowledge to the contextual adaptation. But the humans, if you observe, perceptual to manipulation of intelligence, the human image recognition, hand-eye coordination, to the cognitive reasoning. If you see, we think that a person goes from perceptual to the cognitive. We think that they are intelligent. In the sense, in our childhood, we do very complex tasks such as the recognition of the human faces. Whereas a child recognizing the mother, if you want to program it, though we have these computing capability and algorithms and all, still it is somewhat a complex problem. But whereas the humans, at the very early ages, they are able to solve chess games. But whereas in the case of the systems, the chess games, we are able to, we think that somebody is cracking all chess problems and winning, it is a highly intelligent fellow. But whereas we are able to build the intelligent machines in the sense that we are having the chess games and all that. But what we think in the case of humans as a super intelligence, the machines are able to achieve it in the very early days. But what we think as a general thing which a small child can do, the machines are unable to solve such type of problems. It's quite interesting. Okay. Now, what AI can do, we all know about it. I will not spend much time on this, like natural language processing, knowledge representation, the navigation, machine vision. Like there are several things what AI can do. Okay, there are various applications of AI that also I will not touch, because all of us are aware in the marketing, sales, customer service, information technology, analytics, and the operations, especially the robotic process automation. Nowadays it is coming, and then even the HR people are using the artificial intelligence and machine learning algorithms. In fintech, there are a lot of machine learning models widely deployed. Especially banks, financial organizations, they are able to identify frauds that are happening. And then even in the healthcare, the AI and MLs are widely deployed. Now let us look at the AI, as I have mentioned, super intelligence, general intelligence, and machine learning. So this particular diagram, you just capture it in your mind in the sense that we go from one by one. What is super intelligence, and what is general artificial intelligence, and what is narrow artificial intelligence, and then you have machine learning. And in the machine learning, you are having supervised models, unsupervised models, then reinforcement models, and within that you are having deep learning models. Okay, we will take this particular diagram as the backbone and then discuss in detail. Now, what is driving artificial intelligence? As I have mentioned, artificial intelligence was coined in the early late 1940s, and to 1990s the artificial intelligence it was in the research laboratories. But only when late 1990s onwards, when you are having large amount of data that is getting available through sensors and IoT kind of devices and sensors and all that, number one. Number two, your computing power capability, availability of computing power, even to the small machines like the mobile phones and all that, we are able to have a huge amount of, enormous amount of computational power. So you may even wonder that the Mars rover that was launched by the NASA was having less computational power than a typical Android phone. Okay, so that is the power of the mobile phones that we have today. So the computing power and availability of the data. If you observe here, there is an interesting graph that shows that the number of in the computational power that is available. If you see the number of calculations that we are able to perform per second per $100,000. If you see, in 1900s, starting from 1900s, even we are unable to mimic, even the brain of a fly. Forget 1900s. Even in 1940s, where our digital computers were started, at that time we were not able to match our computational capability of solving calculations or performing the calculations per second, even after investing about $1,000, was not matched to the brain of a fly. But by the year 2000, our processor power has increased, and hence we are able to achieve, say, case of almost a brain of a mouse. We are able to achieve the calculations which your mouse can do, which is equal to the calculations per second by investing about $1,000. Now, if it is the case, by when we will be able to achieve the human brain, we are almost reaching. Okay, by investing about $1,000, are we able to perform the calculations like a human brain per second? We are able to reach people expect that it would be taking around another 10 to 15 years time to reach the human brain capability. Now we have about 700 billion population on this planet Earth, the human beings. Now when we will reach all human brains, people expect that it's about 2080 kind of a thing. Now the availability of the data. So this point already I have mentioned. So these are the two reasons, because of the availability of the data and availability of computational power. Your artificial intelligence and machine learning algorithms are having a maturity, and even the applications are getting maturity in the last 10 to 20 years. Okay. Now let us see what is super intelligence. So the super intelligence is the state where machines' cognitive capability surpasses that of human beings. Okay, it's the simple example that what immediately you can recall is like a kind of a robo film, what we all saw. Okay, so the advent of super intelligence is based on that assumption that the rate of progress, it is basically an assumption that the rate of progress in our evolutionary learning environment is evolving exponentially. That's what is our assumption. Okay, so we do not know whether it is we are going to achieve it in the next 10 to 20 years span the line. Okay, now the point is that next let us see the general artificial intelligence. What do you mean by general artificial intelligence? General AI means that the machine will have the same cognitive capabilities as a human being. As I've already explained in this diagram, it is expected that by 2040 we will be able to achieve the number of calculations that the human brain is performing per second. With an investment of about $1,000, we will be able to achieve it maybe by 2040. So far, we are not able to achieve it. Okay, so that means even for the general artificial intelligence, we have not reached to the point. So forget the super intelligence. So the general artificial intelligence, wherein which you are trying to mimic the human brain behavior or achieve the capabilities of the human brains. Okay, so intelligence, what do you mean by intelligence? Is the highly related ability of an organism to effectively adapt itself. When we say we have to achieve the general artificial intelligence, which is the capability of the human beings, these are the characteristics. One is the learning, memory, reasoning and abstracting, problem solving, divergent thinking, convergent thinking, emotional intelligence. These are all our human being capabilities. So this is how you need to define the general AI. Are we able to when we are able to achieve all this? As I've mentioned, people expect that maybe another 20 years down the line, or even 20 to 25 years down the line. So we talked about super intelligence, we talked about general AI. Now let us talk about narrow AI. What do you mean by narrow AI? So narrow AI focus on very specific use cases. Means that, okay, I developed an intelligent machine that solves the chess problem. Okay, so can I call it as an intelligence machine? Yes, but it is precisely solving only the chess problem. Look at a human. Human would solve the chess, but also the other abilities. But whereas a chess engine can do only that particular task. So that is a narrow artificial intelligence. So this means that artificial intelligence is trained for a specific purpose, like solving a particular problem, the facial recognition problem, image recognition problem. Okay, so it can handle only such problems, and sometimes it may even perform better than the humans in that particular task. That's why you would notice that in many cases, the chess games, beat the humans. Okay, so narrow capabilities. But here the learning is very limited in the sense it is restricted only to that particular specific problem. It can learn within that particular boundaries of that particular use case, and it cannot dynamically adapt to the new situations by coming up with alternative solution. Okay, and in fact that is the use case of general AI. So within whatever your boundary, the narrow AI would solve these particular tasks. Okay, but nowadays we are seeing certain robots which are able to exhibit some kind of a new traits that is beyond because they are very kind of different outliers that we cannot generalize. So what are the typical use cases of narrow artificial intelligence? Your typical NLP, all of us, we are using Google APIs and all that. The natural language processing has matured a lot. We are able to transliterate the text from one language to the other language and all that. And autonomous driving, vehicles are coming up, and then there you have computer vision and image processing is playing a major role, and there your narrow artificial intelligence is playing a role. Okay, and human activity recognition and all that, there are several applications are there. So this is what we are talking about. As I kept repeating this particular image, super intelligence, general artificial intelligence, narrow artificial intelligence we talked about. Now let us see what is machine learning. So the machine learning is an AI discipline, and the key driver behind this ML is to advance the narrow artificial intelligence. Okay, so the machine learning is aimed at achieving your narrow artificial intelligence. So it is a collection of tools and methods which allows computers to learn from the observations, and especially from the data, okay, and also the examples. So in order to improve their performance, so the machine learning models use the data in the case like examples, and then improve their performance. Okay, and predominantly machine learning models are basically statistical models, and that is why if you observe any of the machine learning book, all these books typically are based upon your statistical learning models. What happens during the learning? The parameters of the statistical model are optimally adjusted. So this type of adjustment is actually called as learning. Okay, in the process of learning, in the process of training, what actually you are doing is you are adjusting. Okay, let us optimize this parameter and see what would be the output. Let us optimize this particular parameter and see what is the output. So it is like this. You are preparing a dish. There are various ingredients that you need to make. Some salt, the pepper, all this type of things. So you see what is the amount of quantity. Of course, you may say this many grams and all that, but how it would have come is through kind of a trial and error. Okay, so you learn by experience. In the same fashion, it happens in the case of machine learning. Okay, so this is the very broader diagram. You collect the data and you call it as the training data, and then you need to perform certain pre-processing over the data, and then you define your machine learning model, and then you train the model. The training depends upon what type of learning model you are choosing, whether it is a supervised, whether it is an unsupervised, whether it is a reinforcement model, and then your training goes. Once the training is done, you have to test the model and then export that model over to the real world application and deploy it. And then you take the real world use case event and apply it onto the trained model and get your prediction for whatever it is done. So this is the very, very, very broader the steps that are involved in the case of machine learning. So you need to collect the training data with needed volume and quality. Without a large amount of data, the machine learning model performance would not be that good or not be that much accurate. So you need to collect the data as much as possible, and similarly it should be of quality in the sense that it should fit for the purpose, and also it should be diverse. It should not be skewed data. Okay, it should not be biased data. And similarly, you need to process the data so that in case of any kind of redundant information, missing fields, all this type of are taken care in the pre-processing, and then choose the appropriate algorithm, and then model is trained, and then iteratively modify the model based upon the parameter optimization, and then finally test and expose the trained model in the real world use case. This is what is the typical steps that are followed in the machine learning models. So if you observe, already we talked about supervised learning, unsupervised learning, and reinforcement learning. In order to reiterate, supervised learning, you are going to have the labeled data. Means there is a supervisor who is saying, yes, you have done this for this particular features. This is the label that you should get. So it is kind of a supervised environment. And what are the various algorithms that are there for supervised learning? Linear regression, logistic regression, decision trees, naive Bayes, and then SVMs, random forest algorithm, AdaBoost. Each algorithm has its own use case. Okay, it's not that I can apply any algorithm for any task. No, there are certain features of these algorithms you need to understand, and accordingly that algorithm can be deployed. So the supervised learning, various algorithms, and then their use cases. And obviously, when you perform this, the outcome would be called descriptive in nature, in the sense what happened. Okay, so descriptive analytics people talk about in the case of data analytics. So the descriptive nature, we have to go for supervised learning models. Similarly, the unsupervised learning, wherein which you don't have a data labels that precisely says that look for this particular features cat, this particular features rat, There is no such type of data labels we call unsupervised learning, and it is used when we don't have the data labels. And typical algorithms such as k-means clustering, hierarchical clustering, recommender systems, and the outcome is called predictive analytics. And you have reinforcement learning, which I have already said. The model would learn by experience and reward functions and value functions and all that. So it is used when we don't have training data, and only way to learn about the environment is to experience. Okay, and the kind of outcome what you get is the prescriptive analytics. So in the data mining, probably if any of you have already done data mining and are learning data mining, or interested in learning, you would be doing descriptive data mining, predictive data mining, prescriptive data mining. So obviously your data mining backbone is the machine learning. So you need to take the data, and according to the data you need to go for the learning algorithm, and what is your use case, what is your problem. Accordingly you need to choose the algorithm and then solve the tasks. So there are various technological stack. If you observe, Python, Hadoop, Java, R, MATLAB. So especially Python is the best the programming language and technology, and it has a lot of stacks that supports the machine learning and artificial intelligence algorithms. So as I've mentioned, algorithms, you have regression analysis, decision trees, naive Bayes, AdaBoost, random forest, and all that. And these are all implemented already in various tools, which are Scikit tool, Vika tool, then Mahout, Shogun, like that. There are tools. When you are using these tools, what I've already said was use these tools, but also you should learn about how these tools are working and how your algorithms are actually working. Okay. Now, if you observe the supervised learning, as I've already mentioned, I think in the interest of time, I will just skip this supervised learning. We already discussed about supervised learning, what is meant by supervised learning, and there are two types of supervised learning called classification and regression. The classification algorithm identifies the categorical response in the sense that, yes, for the given data, it belongs to which class. Okay. And in the case of regression, algorithm predicts the numerical continuous values for the given input. Okay. So typically you say that classification separates the data. Yes, this particular data belongs to this class. And regression fits the data in the sense that, okay, this particular data sample should fit into this particular the analysis, the class. So the regression fits the data. Okay. So the unsupervised, as I've already mentioned, you do not provide the algorithm with labeled training data, and typically like clustering, anomaly detection, and these are the best examples for the unsupervised machine learning. Okay. So then you have semi-supervised machine learning, wherein which it's a combination of both supervised learning and unsupervised learning. But typically you need to go and understand what is reinforcement learning. It has so many use cases and scenarios, and reinforcement learning is based upon the assumption that your optimal behavior or action can be enforced by positive rewards that are given for a favorable action. But remember one thing, this will have another negative effect as well, because if the system keep doing only the positive action and not exploring, so that is the reason why experiencing and exploring, you need to have both functions in your reinforcement learning. Experiencing is to reward to the system for positively learning, and also not penalizing the system for exploring. Okay, so both should be there. So reinforcement learning. So if you observe in the reinforcement learning, imagine an agent. Agent means it could be a small robo, it should be a robot control. In the case of robot control, it could be any kind of an agent. It faces a situation, and when there is a situation, it triggers an action. And when there is an action, that particular action, you need to identify whether that action was leading to a positive outcome or a negative outcome. So if there is a positive, in either the case, you are entering into the new state, and accordingly you either reward or penalize. Okay, so the goal of the agent is always to maximize the reward. Okay, and in the sense that it is learning, and whenever it is failing to learn, you can have a penalty for that. So it's a iterative process. Okay, and so this is what we already discussed. Now, if you observe what to do when and all that, imagine you have a problem, and I know you need to check whether you have enough data or not, at least about a minimum 50 samples. If you don't have it, you have to get the data. Don't come to the machine learning at all. Imagine if you have more than 50 samples, yes, then what is your task? Is it predicting a particular category? Of course, if it is yes, we have the labeled data, then go for classification tasks. Okay. If you don't have labeled data, then go for clustering. And so this particular diagram, which of course you can get it from scikit-learn algorithm cheat sheet, you can just Google it and get it and understand when to do, what to do, and how to do, and all that. Okay. So I will not spend much of the time here. Those students who are interested, you can note down this particular the cheat sheet name, and you can Google it and then get it from online. This gives you a better understanding about how to perform, or what is the task you have, and what kind of algorithm you need to perform, and all that. Okay. So we talked about super intelligence, we talked about general AI, we talked about narrow AI, we talked about machine learning, and within machine learning, we talked about supervised. Of course, I have not talked much on semi-supervised, which is a combination of both supervised and unsupervised, but we talked about unsupervised and we talked about reinforcement learning. Okay. Now let us talk about deep learning. What people talk about deep learning, people say there are a lot of use cases and all that. So essentially, deep learning has come out from the neural networks, artificial neural networks. We used to teach neural networks till even now we teach neural networks, but but deep learning has taken the much lead. Fundamentally, it is rooted to the neural network problems, or neural network models and architectures. So what is a neural network? Essentially, it is a machine learning model. If you remember, I have already said your AI, and inside that machine learning, and inside that you have deep learning. So the neural network is a machine learning method inspired by the way the human brains work. Okay, so they are best used to recognize the complex patterns in the way the human brain recognizes in a very unstructured manner. So the audio and the speech, voice recognition. Now we all understand the sentiments through the natural language, what we are talking, the how human brain is performing it. Okay, so again, the neural networks is inspired from the human brain. If you observe from our sensors, like the hands, for us sensors are nothing but like where we sense things, like your hands and the eyes and the ears and all that. And this particular diagram illustrates the moment you observe something from your eye retina, it takes about 20 to 40 milliseconds to reach to the level of of your audio or video cortex, and then the process this particular piece of what we are actually watching. Okay, so from this particular diagram, you can understand that the first hierarchy of neurons that receives the information in the visual cortex are sensitive to the specific edges, in the sense that when you see something, immediately you are saying that, okay, I'm looking at my monitor, I'm seeing my laptop, I'm seeing my mouse, I'm seeing my keyboard. All these things are happening because the visual cortex are sensitive to specific edges. Okay, and while brain regions further down our pipeline are sensitive to more complex structures. Okay, so brain has lots of these neurons connected, as I've already mentioned, and they are providing us the ability to recognize, process, detect, and perform this type of complex tasks. So the neural networks are basically inspired by the way human brain works. Of course, as I've already mentioned, human brain basic element is the neuron, and the neuron looks like this, the biological neuron, okay, wherein which the biological neuron has the the nucleus, and then it is connected with the other neurons through dendrites, and it receives the information and it processes the information within the cell body, and it passes the information through axons to the other neurons. Mathematically or artificially, it would be modeled as a function. It is receiving input from several dendrites, in the sense through various connections, which you call it as the connection input, and every connection would have certain weight, and the cumulative input to that particular cell body, if it is exceeding a particular threshold value, you call that particular neuron is firing. So you call it as an activation function. Okay, so this is how your neural network, artificial neural networks have modeled your biological neurons. So the neural networks, you call that, you have input layer and you have an output layer, in the sense that you are receiving inputs and you are passing the output to the next level of neurons. But essentially here you are getting the output here. Hello.
Yes, sir, you're audible, sir.
Okay, thank you. So if you observe this particular network, the network has two hidden layers, in the sense that there are three inputs and there is one output, and in between you have two hidden layers. So in each hidden layer has about 4 neurons, and all these neurons are interconnected. And if you observe here, information is propagating in forward direction. That's why you call it as a feed forward network. Okay, so it is fully connected feed forward network, because each neuron is connected to the other neurons, and it is fully connected feed forward neural network. Okay, this is the neural network model. And what happens, you take the sample labeled data when you want to perform classification and forward it through the network to get predictions, and then you see the output, whether what I'm supposed to get. If so, then your training is done, your learning is done. If not, you propagate the error. So what is my error? And update the connection weights. Remember, these particular connections across from input layer to the output layer, every connection would have a connection weight. If you observe in the previous slide, if you observe here, every connection has a weight. So understand, very well what is the input you are giving, and what is the output, what you are supposed to get if it is a supervised learning. After all, what you do not know is the connection weights. But remember, it is not that only connection weight, but there are so many other parameters that you do not know. You would be learning and then identifying such parameters. So that is the process of called learning. So in the case of learning, what you are actually doing is you are trying to identify the weights and also the other parameters, so which you call it as the learning. So in the case of your neural network learning, what is happening? You are giving the sample. If not, what is the error? Then you propagate the error back, inform it back, and then adjust the connection weights. And then again, you give the input and see whether I am getting the output or not. So this is the process of learning. Okay, so that happens in the neural networks. In the case of neural networks, again, I repeat, you are adjusting the weights or understanding and realizing the parameters is called learning. Then what is meant by deep learning? Deep learning is a subtype of machine learning, and as I've already mentioned, in the case of deep learning, it requires lots and lots of data. Okay, and probably for the computational power, you may need high performance GPU as well. So what is the difference between traditional machine learning and the deep learning? The traditional machine learning, if you see here, you are giving an object, and by extracting its features, you are giving it to the machine learning model, and let the machine learning model classify it to a particular object, whether it is a car or a truck or a cycle or a lorry or whatever it is. In the case of deep learning, you are only giving the object and let the learning model learn on its own, and then say this particular object belongs to, or this particular object is a car. How can I do that? What could be my model? Obviously, the model would be your convolutional neural networks or kind of a neural network that you need to deploy. People call it as a CNN, RNN. There are several network models out there. It all depends upon the task what you are performing. So if you observe here in the deep learning models, it is end-to-end learning, and also your feature learning and classification, it is done. In the case of machine learning, you need to perform feature extraction and provide it to your classification learning algorithm. But whereas in the case of deep learning, it's end-to-end. You are only giving the objects, and you are saying that yes, my output is car or whatever it is, and allow the model to learn on its own. Typically, these models are neural network models, and they are very deep in nature. We will understand what do you mean by deep in nature after a couple of slides, but now you understood the difference of machine learning and deep learning, and when to go for machine learning and when to go for deep learning. See, nowadays the students, what I see is that, just for the case of to become fancy or whatever it is, or since everybody using, let me apply deep learning, or without understanding the problem context. Imagine you are having a small data set, then it is better to go for machine learning. Okay, because machine learning provide good results with small data sets, and you want to quickly train a model, you can go for machine learning. In the case of deep learning, the flip side is that it requires large amount of data. If you have small amount of data and you say that I am deploying deep learning model, it is of no use, and it is highly computationally intensive. If you go to your faculty and say that, sir, I have laptop, I have deployed my deep learning model, it looks funny. Okay, your model would not be deep learning model, or else you are actually not performing deep learning. In the case of machine learning, the flip side is that it need to try different features and classify to achieve best results. Whereas in the case of deep learning, it learns features and classifies automatically. Okay, that is the other side of the positive side of deep learning. And the machine learning has the problem of accuracy. You can reach accuracy to a particular level, not beyond that. Whereas in the case of deep learning, accuracy is unlimited. Okay, and you have CPU based computations and GPU based computations for performing deep learning, and also cloud based GPU. Okay, as I've mentioned, it is better not to go for the CPU based, but of course all of us are only having the CPU based, but it is better to go for the GPU based environment or cloud based environment. So let us see what actually the deep learning and how these models work. It is basically the neural networks. Deep learning basically builds from the neural network, and there are many different types of deep learning neural networks. How you differentiate a neural network from a deep neural network or a deep learning model? The fundamental difference is that a deep neural network model would have more than one hidden layer. See, what happens is, in a classical neural network models like backpropagation, whatever the problems that are solved, they are solved with one or two hidden layers. But in the case of deep learning models, the number of hidden layers are large in number. Okay. Of course, why we go for large in number is because you need to build the features. Okay, and you need to perform the classification. In the case of classical neural networks, you don't have the task of performing the feature engineering. Okay, you need to manually or by somehow you need to extract the features and give it to the model. But now the model has the task of extracting the features. Okay, take an example of image. When you are giving an image to the algorithm, what actually you are giving is the pixel intensities. And now from the pixel intensities, the algorithm has to identify or understand, yes, this particular pixel belongs to in this particular image or some kind of a thing, and then understand that as a feature and provide that feature to the classifier model. So for that purpose, you need large number of hidden layers. Okay, that's why a deep neural network consists of hierarchy of layers, whereby each layer transforms the input data into more abstract representation. Like, first you need to understand the edges, then the nose. Imagine if it is a face recognition, edges, nose, face. Remember, in the case of machine learning model, you are actually explicitly giving all these features to the model. Okay, so it has to extract the edges first, and then it has to apply certain filters, extract the edges, next extract the nose and eyes kind of features, and then faces, then give this to the classifier model. Okay, So the classifier model, after feature detection, then your classifier model will take it and then perform certain classification kind of a task. If you observe here, there is a convolutional neural network deep model. If you see here, there is an input and the final output as a car or a truck or van. If you see here, there is a convolution layers. Here they are actually doing the features. So the layer consists of convolution layer, pooling layer, and it is repeatedly performing this task to extract the features or detect the features. Once that is done, you give that to the classification model and understand whether it is a car or a truck or a van. And remember, the output would be probabilistic in nature, in the sense that you are giving an output as the probability of this particular input to be car is, say, 80%, say 90% kind of a thing. Okay, so this is another example of CNN. So essentially what is happening is that you are giving an input image and then extract the features in the convolution layer, and here itself you are having several hidden layers, and then you are taking the features, performing the feature classification. Okay, and remember there are several parameters inside. These parameters including number of layers, number of neurons is inside the layers, activation functions that are to be adopted, and these need to be fine-tuned. And the entire process of learning is nothing but optimizing these particular parameters. Okay, now if you observe here, all of you, I'm not sure if you have seen this lady or not. Please look her very carefully. I'm not sure if you have seen this lady or not. Remember, this particular image she is not a human. Number one, this particular image was drawn by a image processing algorithm through CNN model. If you see here, the particular image, it is crafted so meticulously such that it appears as a real human. Okay, if you see here, carefully observe the animation. If you observe carefully the animation, this particular GIF image, the neural network training time it took, the generator, discriminator, and the model is able to produce the images as human faces. Okay, and there are various neural networks, different architectures that are there, starting from perceptron to the deep neural networks. Okay, that is for a different lecture. I think you can have a look at this website called Neural Networks Zoo, in which you can find various network architectures and when to use what. Now you have several network architectures, when to use what. Boltzmann machine you have, then you have deep feedforward networks, then you have coherent network, then you have SVMs, then you have neural Turing machines, then LTMs, LSTMs, like that. There are several network architectures, when to use what. Okay, all these things is interesting, and you need to understand when to use what. So if you see the machine learning tools, this particular slide gives you a better picture of if it is machine statistical models. There is R libraries called NumPy. There are R libraries, Scilab, then SPSS. Of course, SPSS and SAS, there are proprietary. There are open source tools that are available. If it is for general purpose, you have Beeka, Scikit-learn, Shogun. And similarly, if it is for narrowed solutions, as I've mentioned, solving particular problems, then you have NTLK, then you XGBoost algorithms. Okay. Similarly, on the deep learning side, you have deep learning models with the MapReduce. You have deep learning models with GPU. TensorFlow is best example for that. CNTK, and then Theano, then PyTorch. These are all deep learning algorithm. These are the tools that provides deep learning by exploiting the GPU. And if it is for the MapReduce kind of a big data perspective, then you have Spark ML, then H2O, deep learning 4G, and all that. Okay. Similarly, you are having wrapper libraries, Keras, TensorLayer. But my suggestion to all computer science students, those who are listening this particular lecture is, okay, you can use these libraries, play with these libraries, but at the same time, don't simply just call these libraries and then complete your task. But imagine you are deploying a CNN model. You should really understand how actually the model is working, okay, how that particular algorithm is working. Otherwise, what happens, there is a similar to your CNN and kind of learning models, you have a learning model called transfer learning. What do you mean by transfer learning? The model has already learned, and that learned knowledge is transferred, okay, but are we learning from that? That is what is very, very important. Okay, so think on that. So this particular, if you see in the literature, there are literature about what is TensorFlow and what are their licenses and all that. Similarly, when to use, okay, when to use what type of library. Similarly, when to use what type of network architecture, what type of problems I can solve, or what kind of training algorithms that this particular network architecture would be adopted. Okay, so, and are there any data sets that are available? There are large amount of freely available data sets that are there, MNIST, ImageNet, especially for image processing applications and all. There are a lot of data that is available. I suggest you guys to explore all that. Okay, so this is again about the market and all that. I think, you know, you all know very well about what are the various applications, or you can Google it and then get this information of what are the AI applications and all that. Several companies, name any company, every company, whether it is IT company or whether it is a construction company or whether it is a supply chain, healthcare, even pharmacy, almost all companies are using analytics and machine learning. Okay, so there are so many use cases, and machine learning and deep learning are the order of the day, and we'll be continuing it further. And I suggest all of you to explore it, learn more, and there are toolkits that are available. Play with them. Only thing is that you should have, you know, the enormous patience to explore and learn. Okay. With that, I would like to conclude my talk. If there are any questions, I would be happy to take it.
Sir, are there any machine learning algorithms that can be chosen for cognitive behavioral therapies or cognitive analysis?
Yes, sir, but it all depends upon what type of cognitive behavior we are trying to, you know, what type of cognitive behavior we are trying to target. Now, whether it is, you know, whether it is learning, or whether it is understanding, whether it is reasoning, okay, whether it is memorizing, okay, even certain emotions. Okay, it all depends upon this one. But nowadays, cognitive, there are people are using it in two different contexts. One is cognitive, as I've mentioned, in the human brain context. Another one is cognitive in the sense adding context to the application. People are calling it as a cognitive systems. So in both cases, yes, people can use it.
Okay. So if anyone has any questions, you can ask. Else we'll wind up the session.
Sir, I think, you know, if you are recording this, you know, probably please share the recorded lecture, sir.
Sure.
So if any of the students are interested to work or do some projects and all that, please stay in touch. I would be happy to help. Okay.
Yes. Thank you so much, sir.
Thank you. Thank you.
So I thank you for being with us today as a distinguished speaker here. Anirudh, do you have any questions?
Yeah, sir. Hello, sir.
Yeah, please.
Sir, I'm working on some algorithms like where I'll be working on both analysis of audio and video of that subset data set. So, are there any algorithms like where I can combine both the things and produce a desired result?
Uh, uh, I do not understand your question. So you are performing both audio and video.
Yeah, sir. Sir, should I connect with you personally so that like it will be
Yes, yes,
more interactive kind of?
yes, yes. Yeah, you can write to me.
Yes, sir. It might take more time to explain my question, sir.
Sure,
Sorry.
sure, sure. You can write to me.
Okay. Thanks a lot, sir. I will get back to you.
Thank you so
Thank you.
much, sir, for being with us today as a distinguished speaker. It was a very nice lecture, and we gave our students got an insight on how this artificial intelligence, machine learning, and deep learning works. Thank you for spending your time with us for today. Hope to have you connected with the future events also under this ACM student chapter KLS Gupta Institute of Technology. Sir. I thank.
Sure, sir. Sure. Thank
Yes,
you.
yes, sir.
Sir, actually, I would be needing one letter
Yes, sir.
about our event for our
Yes, sir. Sure.
institute. I know the for this accreditation purpose. Okay.
Sure, sure, sir. I'll be
Yeah, please.
sharing you the.
Either from your head of the department or from the principal. Yeah.
Yes, sir. Yes, sir.
Sure,
We'll
sure.
be sharing
Thank you.
it. I thank our HOD principal for supporting us in having this successful event. I thank all the student participants who have participated today and been a part of this wonderful event of distinguished speaker program under ACM student chapter Gupta Institute of Technology. Thank you one and all. So we'll be winding up the session here. Thanks a lot for your support, sir.